Hello everyone, welcome back to the channel Maths with Berlin, and here we are with another probability series, and in this series we will be discussing some great probability questions, and this will be not just limited to probability, it will be also extended to all the other chapters of mathematics. So let's get started with today's problem. So from probability we have got an amazing problem that is known as the law of Laplace's law of successions. So in this problem it is given to us actually. Let me just magnify it a bit. Yeah, so here is the problem. As you all can see, it is given that each of the n plus 1, wait, just let me read it out to you all. What is the question? Because explaining the question line by line is very much difficult here. So there are n plus 1 urns that are there, right? And all of them are identical. All of them are identical. Wait a minute. Yeah. So after that, what it is given to us is that the ith urn that is there. And now wait, sorry. Before that, it is also given to us that all of them are numbered from 0, 1, 2, dot, 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 up to n, right? And each of them have n balls. Now you must be questioning about what is the distribution of the n balls. So the distribution of the n balls is such that if ith urn is chosen, then there are I black balls and n minus I white balls, right? This is the distribution of the balls that are there. Now we are asked to find that an urn is chosen at random, right? And n balls are drawn from it one after the another with replacement. Now, if all the n balls turn out to be black, then what is the probability that the n plus 1th ball is also black? So this is our main question that is there, right? Let me just erase this all so that it's not very hazy. So yeah, so what we do in this question is we try to formulate this in terms of events, right? We try to formulate this in terms of events. So the first event that I choose is that the event such that ith urn is chosen, right? Event that ith urn is chosen. And I choose the event B as choosing n black balls in succession, right? And the event C as n plus 1th ball is also black. These are the three events that I get. Now, what is my probability that is required probability? Now the required probability is P probability of C given B, right? This is my required probability. I think you can understand it because if I have been given B, then I need to find C. Now that's a conditional probability, or yeah, so that is it, conditional probability, right? Now also with conditional probability, I have the total probability here included. The concept of total probability is also included here, right? Total probability. Now what happens is you get the PB as follows. PB given AI times probability of AI summation I equal to 1 to n. Why it is so? It is because you see what happens is AIs are all disjoint. All the AIs that are there are disjoint events, right? All the AIs are disjoint events. Like the probability of choosing the first urn is not dependent on the probability of choosing the second urn. It is not dependent, right? They are all independent cases. Independent cases, right? So what happens is now you can pretty well understand what is there is that you get that the probability of choosing AI, right? The probability of choosing the ith urn is actually 1 by n plus 1 because there are n plus 1 urns and you choose only one of them. And the probability that the ith urn has, n black balls, right? We choose n black balls out of that with replacement is I by n to the power of small n. Now we need to add this from 0 to I equal to 0 to n, right? So here I think I have made a mistake. That is, this must be 0, not 1, right? So after that, what happens is, similarly, you can already get that probability of B intersection C, right? Similarly, you can get that the probability of B intersection C is nothing but 1 by n plus 1. That is the probability of choosing the ith urn. Okay. The probability of choosing the ith urn, and from that ith urn you choose n plus 1 consecutive black balls, right? N plus 1 consecutive black balls are chosen and or drawn out, right? So the probability that we require is actually probability of B intersection C divided by probability of B. So that comes out to be this expression, right? Now as n tends to infinity, what happens? This is a special case. Now our problem is solved, but we are trying to understand a special case, right? This is a special case. Now then the required probability that is there, that becomes this. How do we write this? Right? Or how do we justify this is actually, we know that summation of 1 by n x to the power n x by n to the power n, right? Actually it must be r by n, right? R by n, r is equal to 0 to n is basically integration of x dx when it limits goes to n tend to infinity, right? This is equal to x dx from 0 to 1. In the similarly, with similar fashion or similar way, you can say that this limit when it goes to infinity and this limit when it goes to infinity, they both become of the following formats, right? And hence on solving them, we get that the value is equal to n plus 1 by n plus 2. Now, as a special case also, we have another problem that you can try out is that just a bit modification or a bit generalization to the problem. What I am telling now is the generalization to this problem. So the generalization is that find out the probability that n plus 1th small n, okay, it is small n plus 1th, n plus 2th dot 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 up to n plus mth ball is black. Now the given conditions are same, right? So what you need to do now is that I am telling you that instead of the first n balls being black and then finding the probability that n plus 1th is also black, You now try to find out the probability that the following given balls are black. Right, like the last m balls are black. You need to find out that probability. So this is a particular generalization to the problem. Putting n equal to 0 and m equal to n, you can already get the following problem. So the solution to this problem will be posted in our discussion group, and those who want to join it, they may find it on the channel link, main page of the channel. So that's it for today. Thank you everyone.